Okay, guys, I'm going to show you how to do 3 questions today. So, well, first of all, are you guys seeing this right here? Because there's 2 red dots. There's one here, and it's on my screen, but I'm not sure if it's on yours. And it's starting to distract me. I'm like trying to circle around it to get rid of it. So anyway, we're trying to find out the measure of MLO in this figure. So, M is here, L is here, O is here. Well, obviously, you probably figured that out. So we need to find out what the angle number of this angle right there is. Not this right there, just there. And so, what we need to do is, first, we know that this is 55. Alright, so that's 55. And this is a right angle. And we know that it is a right angle because 55, and then if this was 90, which could possibly be the answer, we'll see soon. I like circling things. So what plus 55 equals 90? So what we're going to do is we're going to take 90, we're going to subtract 55, and we are going to get 8, another, what am I thinking, add 1, 5, and a 3. So this would need to be 35, that would be 55, and the answer would be 90. And there you are. There is your answer. Right there. Oops. Messed up a bit there. There is your answer.
Okay, just to add a little bit to what Jaden was trying to do. Jaden did a good job of trying to deduce things, but all you had to do to answer this question is go to page 395 of your textbook. And it says, a tangent to a circle. A tangent to a circle is perpendicular to the radius at the point of tangency. So just, you can see that this here is a radius because it comes from the center and goes to the outside, right? And you can know that this is a line of tangent. So this point right here, where it goes, that's going to form a 90-degree angle. That's why the answer is 90 degrees. So thanks, Jane, for putting your explanation on it. And if you just look at the text, 395, you can find a simple way to figure out that that's 90. But I did like the way that Jaden found out that this angle here would be 35. That's some good math there, Jaden. So hopefully that helps you out with that one.
Alright guys, this is the second question I'm going to be doing for you, or teaching you how to do at least. This question is quite hard to read, as you can see. It says the measure of BEF in the figure shown below is, so we need to again find out what this angle is, right? Not right. I'll erase it for you. Show you exactly where. Right there. That angle right there. So what we need to do here is I'm stumped with this one. Maybe we can get someone else to do it. Hopefully, because this one's got me. Hold on now. I'm going to stop and try to figure this out.
Okay, just to help Jaden out a bit with this one, again, it goes back to what I was just talking about. You have a tangent line. Now, it does say BEF, but obviously this would be a radius, right, which is half of the diameter. And when there's, like I just said, if this here is your radius coming out and it comes to your tangent line, it forms a 90-degree angle. That's why the answer is D. So it's very similar to the first explanation that Jaden was trying to do. But again, I'm liking how Jaden's deducing things and trying to figure things out. So we'll definitely keep up the good work. If you listen to what Jaden said before, if you had 90 and if you had 50, that would equal 140. The sum of the angles are in a triangle is 180. And if you subtracted 140 from that, that would give you 40. So that would tell you what this angle is right there. All right, so that's a little bit of extra there. So Jaden, you're doing a good job. Again, just look at page 395 to help you out with that one.
This angle.
All right, guys, here we go. Oh, that's just a warning bell. All right, I'm gonna teach you guys how to do this question now. So the question states, if a chord were drawn from point P to point T in the figure below, PT hole would have a measurement of what? I'm guessing the rest of the question, since, you know, it's cut off kind of right there.
You did not have this angle.
So,
Multiply this by 2 in order to get this angle.
okay, if a chord were drawn from boom, boom,
Okay, there we go.
boom. So let's just draw this line here. Let's put this line right. Oh, it's not working. Work. The line won't work. Okay, pretend I have a line right there. Okay, we're trying to find out the angle. Oh, there we go.
Everything seems a little bit easier.
We're trying to find out right there. So this is going to be probably
It's a lot easier. 'Cause in the
a
answer it says
bit of a harder one.
you need to know that.
So I'm gonna guess that if we do divide 180, divide it by 3, because this is an equilateral triangle, that if we divide 180, which is the ultimate number of all these angles put together, so if we divide 180, that was bad, 180,
So for example,
put a 3 over this, add a 6,
the chord
6,
could be like that.
so it'll be
Or
60.
like that.
So clearly I'm
As long
wrong.
as they're not,
I don't know.
they don't go through
I don't know.
the-
Hold on, wait, hold on. If a chord were drawn from point P to T in the figure below, PTO would have a measurement of what? So we're not trying to find out exactly what these ones are. We want to know what this one is. I knew that. So,
And make sure you draw your squares to show that you have a perpendicular angle.
you know what?
Or 90-degree angle. And just on the other side of it as well.
Man, am I ever smart. Okay, let's restart here. Oh, clearly we can't restart that part.
And then you need to do the same thing
Weird.
with the other chord that you have.
Okay, you know what? No, you screw it. Okay, so this line is right here, right?
It needs to make it T.
And so, if you, since, you know, none of this will, maybe if I, like, back it up a bit. Back it up. Oh, there we are.
With your B and D angle, it's going to be on the inside of this arc.
I'm backing it up as far as I can, and we're good. No. Okay, so basically what I'm trying to say here is, if we were to put this perfect line right to there, if we were to do it, this angle right here would be the same as this angle right here because of the arc.
So normally what you would do, I'm just going to
So, without this angle already put there, that means that this one is the same as this one. So that means that 24 degrees is over here, and that it must be the answer to this one. Ta-da!
All right, Jaden, you did some good work on this one again too, but you got to look at this a little bit differently. Okay, just so you know, you have this is a key piece here, the 24. All right, so you have to know what that is. The key thing again of knowing, just like we said in the past, if we extended this line right here, this would be a 90-degree angle. Okay, so you got 24 plus 90, right? Which is going to give you a 114. Now, because we know that, we can figure out what this angle is here. Oh, because as Jaden has said before, the three angles have to add up to equal 180. We know the other two angles add up to be 114, so we subtract, and we get 66. So it has to be D, right? Oh, no. That's not what it's asking for, right? That's telling us what this angle is here, the 66. But because these are two radius that are coming out of here, you know that side has to be equal to that side because they're radius, just like spokes on a wheel. We are looking at this angle and this angle, right? So PTO. So really we're looking at that. But whatever T is, that's what P has to be as well. So as Jaden, the wise man that he is, also said before, and we talked about already, the sum of the triangle angles of the triangle have to equal 180. We know that O equals 66. Okay, we just figured that out here. But we don't know what the other angles are. So we use our good friend X. But how many X's are there? There's 2, right? So we're going to add 2X. Those three angles would be that. Another way you could show that too is it's 66 plus X plus X, right? Then that just means 2X. All right, so just so you guys know that. Those angles have to be equal, again, because these two sides are equal because they're radiuses. So all we do here is we subtract 66 from both sides, and you get 114 equals 2X. Now you just want to find out what one of the angles is. So I just want to divide both sides by 2. 2's cancel there from previous units that we've done. 2 into 14 is 57, equaling X. So that's what that angle is there. And that's also what that angle is there. So your answer has to be C. Right? So hopefully that makes a little sense. Jaden, once again, good job on your trying and figuring it out. And hopefully what I said makes sense. Thank you.
Okay. We're doing math. Here we go. So what we need to figure out is the measure of MLO in this figure is, well, as you can see, M to the L to the O is right there. So what we need to figure out is what this angle equals. And where's the eraser? So, as it won't let me erase. There we go. So what we need to do is, so what we determine is that I have no idea what I'm doing with this. But I do know that this is 55. Oh, I'm still on eraser. This is 55. Now 55 is an answer. But I don't know because, as you know, a triangle, with any triangle, the total amount of degrees is supposed to be 180. So, if this is 55, then that means that the angle cannot be 60. Wait, yes it can. It can be 60. The angle, I'm not too sure what I'm doing here.
All right, Jaden, I'm glad that you tried it out. As you can see here, this is number 19, was exactly what you did on your first slide. So once again, the answer would be 90 because you have, again, you have your radius coming out and you have a tangent line, and where the radius and a tangent line meet at the point of tangency, you have a 90-degree angle. That's why that. Again, that's on page 395 of the text. All right. Again, Jaden, good job, buddy. I'm impressed that you tried it, and hopefully between what Jaden was trying to figure out and some of the additions I have, it makes a lot more sense to you guys. Thank you.